So thank you so much for joining us, and I'd gladly introduce Jim to take over the session and get us through this masterclass work plan. So Jim, over to you.
Okay. Hello, everyone. My name is Jim Gitonga. Okay, let me first share my screen. Okay. Desktop. Yeah, cool. So I believe everybody can see my screen basically.
Yes, go ahead.
Okay, cool. Yeah. So my name is Jim Gitonga.
Sorry, Jim. Maybe you can make it full screen.
Full screen, cool.
Yes, full screen mode. And yeah, thank you, Winnie, for that wonderful introduction. My name is Naida Mugese. I am the finance and incubation lead here at Wilgrow Africa. And like Winnie rightfully said, we are a social impact investor and business incubator in the healthcare sector specifically. So thank you for joining us today. And we're always happy to get new pipeline and any companies out there that are actually in the healthcare sector and are building interesting health tech solutions. So we have a link on our website, just in case I drop off early, a link on our website for you to apply for any funding opportunities, technical assistance, and reach out to us in case you need support with your startup. So I will leave it to Jim to continue with the next session. Thank you, everyone.
Okay, cool. So my name is Jim Gitonga. I'm basically a software engineer at Asteric Software, a US-based company. That's why I write my software. My background basically is that I'm a biomedical engineer by profession, but I basically chose to write code. So code is what I do day to day. And that's my background. So now today we'll basically start with something we are calling the software masterclass. And we are just going to cover 3 topics, which are basically to some of you might be deep, to some it might be shallow, you might have encountered them. And the first one basically we'll deal with is what we call technical debt code. Then from there, we shall see what is basically the debt code and how basically do they accumulate in startups, because I know most of you are in startups and you are having companies that you are running. Then we'll basically now look at something a bit of now what is foregone, which is basically now the software testing and the quality assurance. And here now, that's where now, if your code basically has got a lot of technical debts, basically now on the testing becomes a problem. Then we shall end by looking at the best practice. So basically now, when maybe you've always been hearing the term technical debt, it's always a metaphor, basically just referring. So what we mean by technical debt is that we are having problems or extra work that is basically arising due to the architecture of your code or the system or your program. Assume, I will take an example, assume someone is designing a BP machine. So as the time goes by, the software they are writing, you realize the software, as time goes by, the software becomes a problem and problematic, and it becomes easy to maintain. And then as here in Kenya, as we say, basically now you do it maybe basically because of the short term. Assume, I know some of you are in startups and you're doing it very fast. You're designing code very fast. You want to show the investors and you want to show them what's happening. So you end up now not looking at all the case engines. So you design it on the short term basis, but you're not looking at the long term now. And that one now becomes a problem, because now at the end of the day, remember, your code has not been thought through. So basically meaning the architecture. And when I talk about the architecture, I'm talking about, assume we are coming from backend to front end. We are talking about the application layer. We are talking about basically the business logic that is going on. So, and also the network layers that basically you might require to those who are hosting their own services. That is one thing. And now now we are having these debts now, remember, these are debts that are coming. These are debts that are basically accumulating because you want to fasten something, or basically you just want to run over something. Now that one now means what we've done is we've introduced bug to our system, because you've just cut the corner. You've just moved through the corner. When you introduce the bug, remember, this code might be the one that is running 10 years from now, or 20 years from now, or 15 years from now. That one now means the code will become unable to be maintained. And maybe some of you are software engineers, you've been in a code base that you've looked and it was so ugly. And as we always say, let your code be like music, that when someone looks at it, they can basically look at it like relics. And that's the basic point. And when you've written well-written code that is basically has got no bugs, and you've thought through and you've seen through the architecture, because the first thing, if you want to avoid the technical debts, the first thing you should do before you write any code is think about the architecture, think about the business logic. How do they interconnect? How does your backend connect with the front end? Now, that's another thing. And then because now we've talked about maintainability. Now, remember, the code continues to grow and grow and grow and grow and grow. So that one now means with time, it becomes unable to scale. Scalability becomes a problem also. And then now remember your code, since now it is accumulating debts, and these are problems that are coming on and on, meaning that your code has got a problem. It keeps on crashing now and then because there is a bug in the system that was introduced, either assumed by a library that sometimes that you use that was not not reliable. So that one now means with time your system now becomes unreliable. That is why you always be having in your system that you're having shortages, and now and then your server maybe is down, your application is crashing on the users now and then. Then now we have to look at something here we are talking about, which is basically the types of the technical debts that now are introduced. The first one we will start with basically is the design debt. Now, whenever we are talking about the design debt, I have said this, before you make any application, before you do anything, you write in the software, the first thing is you have to sit down, you have to see how do things interconnect, how are things moving in your system. Like now, you will have to ask yourself, assume this is my front end, this is my back end, how will I push the data to the front end and to the back end at the same time? You have to ask yourself now, which security measures basically can I use at this point? Because now you have to know how you are designing, and then now assume you have got very many users. So that one now means you'll start now thinking, assume of more and more servers, or assume you'll start thinking about now more storage in the space. So that one now comes now to the design part. Now, and when you've not thought about that, assume now you just designed your code and you hosted it somewhere, assume, but you have more users than your resources in the machine you hosted in can support. That one now means now it's a problem. It will not scale at the end of the day, and it will not be reliable. And then another technical debt now we have as developers is what we call now the testing debt. Now, the testing debt, I know most of even I myself sometimes being a victim. When we write code, we don't write their test. It's very important to write the test. And today we'll go through some code. We'll see basic code that very basic, and we shall see the technical debts it has in it and how we can maneuver through it. So basically meaning that because when you test your code, it's always saying test before you trust. That's the point. Because remember, this code you are drawing, it might be very big. It's very important for you to be able to test, even though you'll not test all the parts. What you are talking of, writing the test for your code. Both, we shall see that one. Now, the other thing is another problem is, I know also you've encountered now, is documentation debt. When, for example, you inherit a code from somebody, you look at the code, you don't connect when does it start from or when does it go to. Because I remember sometimes back, there's a code I inherited somewhere in my first company. It was very terrible. There was no documentation. You don't know where you are coming from. And remember, you're writing both from back end to front end. And now that you don't understand even why the logics are that way in the code. And assume now is a 10x engineer who wrote that code. That one now means you'll have problems struggling, understanding why this is this. You might even end up pouring some code off the code base because you assume that doesn't have work until things fall apart. Now, it's so important for us to learn. Another debt is documentation. If you are a developer writing the code, please make sure, think of somebody who comes after you. And this is the point. Remember, you'll not always be there in that company, assume, forever. But now documenting your work and what you're basically just doing, it's very important. And there are tools basically just to do that. And then now the candidate. Now the candidate is even the way people write their code. Sometimes you've had, I know some of you have undergone through what we call code review, and the senior dev just says your code smells. So basically meaning that it doesn't meet the threshold. It's very low and it's of low quality that it cannot even be pushed because it has got a lot of problems, typo errors. Assume that I know there are some people here who have done assume a language like C. If you looked at most of the C code bases, it's very terrible. because you look at someone naming okay, it has gone for naming assume int A, saying just int A. They don't say what int A is. So when you look at a code, assume you've met unknown variables like 100, you don't know what they are. So basically that's another part where the code brings the candidate. Then another thing you have also to remember, if you are now in health, you have to understand the domain standards, and that is where now most of the health startup basically fail on the domain standards. Remember, the software you are writing, and I will always keep on telling people, the ISO, it should pass all the ISO standards, because whenever you are dealing with this is the human body you are dealing with, assume under some values or some human recommendations, so it must pass at least the basic ISO standards. And assume if you're in designing a software to run an anesthesia machine, that one now means you need to know how the anesthesia works and what are the criteria that governs the anesthesia itself. So it's very important. Assume somebody is writing a BP software for the BP machine, they need to know how does this software, how does this machine run, and then at the same time, how does this is this software complies with the ISO standards that are basically required? Because in each and every domain, you will always there are standards that are there. You need to basically follow, because if you don't follow, you will always realize, even when you take your product to be accredited, not be taken to the market, it will not scale, and at the end of the day, it will be rejected because of these standards. Standards basically fail a lot of people, especially those who are in health. That is why you find we have very few medical companies that are dealing with the softwares and other recommendations. Then another thing is also now the code complexity. You have to remember something now. The code complexity, okay, it comes as also the code grows, and assume you have a function that you want to do things, but you end up now, rather than writing 3 functions, you write one function just to picking off factor or values for one function. So basically, meaning when someone comes to debug the code, they might not know where the problem is. But now, because now it brings code complexity, and there's something we'll see about the code complexity and its problems. Then about the legacy code now. The legacy code, remember now, when the code now is, your code will always keep on aging, meaning you will be pushing version this, version that, and version that. So meaning that there are some people who will be using your previous code, assume it's your version 1.10, blah, blah, such kind of stuff. So basically, you need to remember, you need to be able to support them. That is why now there is always a problem. You find you are using a software, but the company says they don't support the previous versions. It's very important for you to have a way of supporting the previous legacy code until all the users basically are onboarded. You've seen these bigger companies like Microsoft or Apple, before they shift to, they say they are no longer supporting an operating system, they take like 10 years before they say a certain operating system is not supported anymore. So basically, meaning they have been supporting the users and they have been telling them, we are moving to the next level. It's very important for you to know now to manage your legacy code, because now the legacy code, as time goes by, because assume even the stack you'll basically use to start is not the stack that you'll basically use to end. But remember, some of the code now you'll already have shipped in some devices, in some gadgets somewhere. So now the users might just be saying, we don't want to change that. So then another thing, now we'll go to managing your technical debt. So it's very important now, whenever you're managing technical debt, I have said, yes, as guys, we are startups, assume, yes, we need to ship these things faster. We need the investors to say, basically, we've done the work, and we need them at least to understand all those things. Now we have to prioritize between balancing the short-term goals and the long-term goals. Because at the end of the day, remember what you might write, the main logic of your program that you might write it so fast, and it does not cover all the case changes, and then the developer who comes later on after you doesn't even understand what is happening, because now it has got a lot of debt, might be because of the complexity, might be because of the documentation, might be because of the design, the way you implemented it, it becomes a problem. And I will say this, let your code look like a library, like where someone can also pick objects from it, like they can just pick something, learn from it. The companies have, after the first company I've seen, the other companies I've worked in, basically, when I met their code base, it was so good, such that the code itself even explains. You are able now to see this developer was just like singing a song. These are just beautiful lyrics as they just write the code. It's very good, not complicated. It's very easy. Components well defined, and that's the point. Then the other thing is that you also need to identify the areas in your code base that need attention. It's very important. Like assume your main business logic, and I'll keep on repeating this, your main business logic, you need to be able to know how is it functioning? Is it really as the par as what is supposed and as per the goals that you basically need? Is it what's and you basically need to, you have to pay attention to all the parts of your code. And it's very important for you even to understand how even your code base is mutating daily. It's something that is very important. Then we have to talk about something here. Now, to be able to address, assume the technical debt, there's something you have to keep on checking, refactoring your code. Whenever you write your code, go through it, check what have I missed, what have I put that is unnecessary, which variables have I included that are necessary. Remember now, even the technical debt, because assume some of the variables will define and not use, they are consuming memory, because all of these will just be found in register. So it's very important for you to be able to know, okay, does it meet? Does my code really look good? Can somebody look at it and say, this is a beautiful music? Then the other thing is that you have to keep on now improving the documentation. And I've said that because I know most of you here, we are startup. The point is, even assume now you might be here, but the developer is writing a code for you, you're hiring somebody to write the code for you. Make sure when they are writing, tell them to document what they are writing. It's very, very, very much important. That developer, one day they might say, I'm gone. So if they're gone, what happens? That's a problem that comes into the company. And that is how now you start struggling. And that's why we now say the rubber meets the road. And because you basically don't even know how to interconnect, meaning even the other developer who comes on board, they might end up getting blamed for things that it's not because of them, but it is because of the poor code base that basically they inherited. Then the other thing is now you have to keep on now increasing the test coverage, and it's very important, test coverage. And I've sent tests, both we shall see the basic test we shall look at. And now they always maintain the modular design. It's very important. Take point is please maintain modular design. What I mean by modular design is break your problems into smaller problems. Assume you have a problem, keep on breaking it, break it until now you come up with a final solution. Don't write all the final solution once. Just break it down, take time, break it. Remember, this is music you are writing, and these are the lyrics. Somebody will nail it. So it's very important for someone to inherit the lyrics of your code, and they need to be able to like say this is a music that is basically moving in their heart, and it's convincing them. They need to understand it, and that's the most important. And another thing is code refactoring, and I will not repeat it again. Please remember, please refactor your code after you write it. Before you commit, before you push, before you build, refactor your code. It's very important. That's one aspect we have to look at. Refactoring means that you have to look at it, check what have I introduced which is unnecessary, check what have I not introduced, check what have you not done. And now on the code refactoring is whereby now you also come up with to do, because assume you've trying to solve a problem, you've not been able to solve it. So meaning that you've left it for the next day, assume. So basically you need to remember where you started, where you left. And it's very important now to keep on. It's very important. You just say you left it at this point and it needs to be done this and this. Keep on writing even to do's in your code base. It's very important, such that even when another developer comes, or you yourself after 2 years, or after even 1 month, because I myself involved, I write a code today. After 1 month, I come back to the code. I don't. Sometimes I start getting confused even what I was implementing there. But when sometimes I write to do's and also making sure I comment on my code, not making that commenting, but just commenting and saying what a function basically does. It's very important. And when I do that, it becomes easier for me to just go back and even look at my code itself. Then another thing I'll repeat is, for you to manage these debts, please understand the domain standards. Now, the domain standards, and I keep on repeating, it is the rules and regulations basically that are set there. And remember, assume you are designing, the people might have assumed somebody here might be designing a menstrual application. Now, whenever you're doing that, there is the ISO standards that basically now govern the human health. That's one thing. And another thing is also about privacy issues. What can happen when the data leaks? So you have to be able to be sure, have you covered all the standards that are basically there when you are dealing with a specific domain? So it's very important. Now, then we'll look at basically how we check the technical debt metrics. And I hope now everybody now has understood what is technical debt. Are we all together?
Yeah.
So it's coming on well. Is it anything that is not clear?
Well, I think it's
Any
for me.
question for Jim for them to go ahead?
Yeah,
Isaac?
Yeah, thanks very much. It's going on well. However, I would like you to explain more about the ISO standard that are specifically related to software testing and how they could be incorporated into the design and development process.
Okay, cool. I have written them. We'll see them. They're high end here. They're somewhere here, but I will come to them. Yeah, they are basically. Yeah, we have them.
Okay.
I'll come by. Yes, it's on the quality assurance there before, but let me just cover this, then I will come back there. Okay, cool. Then another thing now we have to look at now is a technical debt matrix. Now it's very important. I say now something we basically call the code complexity. Code complexity basically is how much your code is complex. We refer to it as this term here, cychromatic complexity. Cychromatic complexity, assume I have a function. This function is doing a lot of things, assigning, rendering things, changing things. Assume it's just doing updating a lot of things. Now, you realize now as the time goes by, as your function basically is just becoming cyclic in a way, basically, because now it ends up becoming cyclic in a way. So it becomes a problematic, because at the end of the day, it will end up shooting yourself on the leg. It's like something, the way we say nowadays, don't use a go-to statement. It will at the end of the day shoot yourself at the leg. So one thing you have to check is if your code basically or your function is very complex, break it down to avoid basically now the code complexity. It's very important, because now assume here we have 1A, we have 1, we have 2, we have 3. Then again, we also assume we come from 4, we go back to 1, assume we come from we end also number 5 here, from number 5 we go back to 2. Like we are just iterating through things and through things. Now as now the code continues to grow, you realize something, it becomes a problem, and now the complexity increases. Now the cyclic part of the code becomes big, and now that one now means also now the code complexity now it continues now to be high. Then another thing is we have to talk about the code coverage. Now I talked about the code coverage and I mentioned something about the test. One thing you have to remember is this: please make sure your tests have basically covered everything. So that one now means now that you are basically aware, assume if it's the login, you've basically looked at them very well. If we have the basics of the login, you have to also understand the privacy that is involved. You have also to test, you have to automate testing, and we shall see how it's basically done. Another thing also now you have to look at now the matrix is for you to gauge now how large your technical debt is code duplication. Now on the code duplication, I'll give a simple example. Assume I'm writing a function to strip off IDs from people. From the people that are coming, or just encrypting numbers or encrypting people's details. Now you realize rather than me writing just one function just to do that and then I just be coding it, I just everywhere I just go, I write a new function to do that. Remember that is just basically just code duplication, and at the end of the day, you are just making you are just increasing the technical debt for no reason. And then now there's another thing also we have to check is the code churn. Now the code churn is basically, we are just checking how is your code base basically changing over time. How are you basically changing things? And now this is now where you have to be very keen. Here now I have to speak of this. There are people here who are using a lot of libraries. Some of you end up, your code base might look as if it's made of libraries. Now here you realize somebody waits for library, assume this version and this, they end up updating. Now it means now those libraries was getting updated. There's something that is happening in your code base. There are some things you have to keep on checking and changing. So please, even when you're choosing a library, be careful of the metrics that are of the way the library, the stability and the support they also give. It's very important, because now that one will end up forcing you change things in your code. Assume now, like there's a library I used the other day. When I updated my code base with the library, it changed the whole user interface, the UI, and I was so much shocked. I thought they uncovered that. So that one made me change the library and use a different one for that case. So that one means now, you see now, because I had to go changing things, because now assume the incoming library, it is ejecting other dependencies that are unwanted. And then now, This is another thing is now the defect density. Now, the defect density is basically what we are talking of. And I will keep on. Please remember, keep your functions simple, or classes or objects. Keep them so simple. That one now means now let us not find a function, just single function having 1,000 lines or having 1,500 lines. It's very important for you to note that. It's very important for at least use modularity. There's a term we called there before, the modular design. Use the modular design. Break your problem into smaller bits, make it until it reaches a point now where it is ripe for. I mean, the function now are smaller and smaller, and they are easy to understand. Rather than you having one function, doing 1,000 things and having 1,000 arguments, that becomes a problem. Because I know some of you have been in a code base where basically assume the arguments that somebody is passing in a function, it's more than 20 or 10, and you wonder what are they thinking. So it's very important for you to break them, because remember, the more the complex your code gets, the harder the debugging it becomes, because you're going to have even a problem in debugging because you don't understand where the problem might be coming from. Then another thing, which is basically here, the last is basically the technical debt ratio. And this is now the metrics we use now, the time to fix and to develop new features. Now, this one now means is now if your code base assume has got a lot of technical errors, technical debt, that one now means rather than you developing new features, there is something that will be happening. You'll just start maintaining other features, just going back and just dealing with bugs. And that time, basically, you could have used it to develop the new features. Because now, assume if a code base has got a technical debt, that one now means that it becomes even hard to maintain. It becomes even, you don't even feel like entering into it because it's just a big forest. And I've said, let it be a song. That one now means if I meet a music lyrics, I can add my lyrics myself. Then also the code base be the same, meaning that it will become easier for you to develop new features. Because there are some code bases I know some of you have been into, where you're trying to develop the new features and you realize you are hit on the wall. Like there's nothing you can do beyond that, because now the code base itself, unless it is rewritten, and there's a very simple case scenario you've heard about Twitter the other day. There's something that happened. Elon Musk saying that when you went to the Twitter code base, it's unreadable. I don't know how that true is, but assume now it becomes hard now to change the code base until some things start to break anyhow. I don't know how true that is, but I don't know. But now assume now such a code base, and maybe developer designed it, or someone who was reviewing the code decided to push the code, so it becomes a problem. Okay, cool. Now, here is a basic code. Now we go to a code demo that has got technical debt. I will give you 1 minute, just look at the code, then we'll check now where the technical debts are. And one of you will basically tell me where they think there is a technical debt here in this code now. The code looks nice, good, yes, but someone will just tell us where. So can someone tell us what they think, where there is a technical debt in this code and a problem to the developer who inherits it?
Anyone? Stephen, would you try it out? I see a comment from Samuel.
Okay, he has commented. He said, okay, Stephen to Basa. But this is one I'll come back to answer, Stephen. Well, there is, Stephen is saying 89. So Stephen, what do you mean by 89?
That's Samuel who said 89.
Okay, so okay, cool. Yeah. Samuel, what do you mean by 89? So, okay, I will explain then. So what you see in this code, the first thing is that we are having a lot of if-else statements that are basically we can just cover them with just writing one of the, we just put the values in a dictionary, and basically we just now just look through them rather than us now writing and writing and writing and writing other things. And then another thing you should note, there is another technical debt here now. There is no range of values. We are not checking if there is any range of values in between here. So meaning that any value can be just a value. And then another thing is there is the type system. So meaning that even the values you are basically entering for this historic and the historic, we can't tell if they are just letters, they are just numbers, they are just, or they are just float numbers. We can't tell. Now, that's why now on the next part, okay, let me cancel this. Okay, cool. Now, this is the code now of send. Remember, check one thing we are having. We are just having longer lines, which we could have just have simplified, and also just we would have checked other things. Now, here is the simplified version of the code. We just put it, the BP ranges just once, and another thing is we just go through them and check the marks in between the historic and the historic values. And that one now means now we've already solved the technical debt that was basically there, rather than us having longer nested if statement. We've just solved it using a dictionary and just mapping it to the brand pressure range values. Let's continue. I'll send this one, you can just go through it. Now we'll go to the next thing now, which is a software testing and a quality assurance. Still, this code that is here, I want you to note this code that is here, still we've not even removed all the technical debts in it. But now we will see now how writing our test cases basically will help us, will enable us check, do we really have something that we are missing in our code? That's another thing. So we go to software testing now and the quality assurance now. This is now another thing, the big elephant in the house.
Jim?
So yes, hello?
Before you proceed, anyone who has any questions from what Jim has identified as a technical debt? Anyone? Okay, Jim, please go ahead.
Okay, cool. Now we go to the next part, which is basically now the testing and the quality assurance. Now, these are another thing that I know some of your teams, your startups, you might not be having the QA people, but at least you can also have somebody who can just act for the QA. But now the software part is only where I see the devs basically doing the testing, but you need at least to have these two. As much as you are using you are just the developer is just testing, we also need to have somebody who can check if really we've met our goals. So whenever we talk about the software testing, it's basically we are just evaluating, does it meet the requirements that are basically the way it's supposed to work? Assume now I'm having a function of like adding 1 + 1. Does it really and that? Assume I'm having a function now of getting names of the people from the database. Does it really do that? That is one thing now. And because that one now, when you are testing it, it's basically what you're trying to identify in your code base. It's the defects or the bugs in the software. And now it's very important for you to note that. Then whenever we talk about now the quality assurance, we are now talking about the standards. Does it meet all the standards? How was it designed? Now, on this point is now where we will also talk about established standards. And now it's very important because as you might say, if you are designing for a specific domain, you realize they require specific standards. And then the guidelines now, the process of software design, how did it move? That's when also the quality is basically coming about. And then now the monitoring and the compliance with the standards out there. I also know this. We have local standards and international standards. You have to keep an eye and check on something. It's like the other day, you would have noted the UK changed the data law protection rights. It's so important for you to note what happens when you break such a law. What happens if you assume your software doesn't cover that? That's another thing. And then also, you also need the quality assurance. Also, what it does is, it's also, you are trying to identify on the areas to improve. And the point, and please note this, the quality comes from the point, what were your aims? Does the system now meet the specified quality standards. That's the most important thing whenever we talk about a QA. And remember, it's a process oriented. QA doesn't happen in one day. QA doesn't happen in 2 days. It's a continuous process, and you have to keep on checking on that. Now, we have to talk about now, the one thing we have to talk about now, because we are talking about the test and the rest now, is the type of test. Now, on this now, there are people here who are writing the code, and now you have to be very keen on this point. Whenever we talk about the type of test, please remember there is something you have to check. It's the unit test. The unit test means, assume now I have a component that basically is getting the user's names, assume they're getting the user's brand pressure. You have to test that. You have to basically check, does my test work? And remember, write the test to do that, and you can write them and automate them. And then another thing is that you have to check is now another very important thing is integration testing. Now, integration testing, assume your software basically is using an external API. So basically you have to check, does it really connect, or it's just a bogus thing? Because some of your programs, I know they'll be using even webhooks. So you have to test the systems you've used or you've integrated. Assume is a payment system. Assume you have to check, does it really, assume is Flutterwave payment system for the patient, or the rest you are using just for the patient to pay. You have to check, does the system really integrate well? Is it really cool? Then now, whenever we talk about system testing now, it is we have to talk about, does it test the whole system? Like, can you get the test of the whole system? Is everything in your system basically running? Rather than now saying, I tested it last night, it was okay. Make sure before even you take your product to the customer, every point, every inch is tested, even the displays, and then test on the system testing. You have to test, assume now is a mobile device, assume now you're building an Android application. Now the point is, you have to test it on a different platform, on a different Android versions, and on a different screen sizes. I have a friend whom they are designing a software for a company. It was only it was only working in one mobile phone. It was never working in other mobile phones. So the point is now, it made them now realize what their software was basically lacking, and they went back and they did everything. Now, another thing is that acceptance testing. Now, you have also to check this another thing now here also. How do users now take that? Do they really accept your product? Are they really taking into, what are they saying? Some of you, you have your projects that you're basically just piloting somewhere. You just put them in an hospital. You've just given, assume to 2, 3, 4 people to test for you, 2, 3, 4 companies to just do the testing for you. You have to basically check, how do they take it? And then you have also to check what are they saying back to you. So another thing is now performance testing. Now on the performance testing, remember this is a software, and now since you are a startup, assume growing, or you are a big company growing, no user will want to use a slow, sluggish application. You have to test, how does it perform? And then on performance, remember now here, there's one thing you should note. I know most of the developers here have got a computer that has got a 16 gig of RAM. Assume that it has got a 1 terabyte. Assume also now it's a one MacBook. So when even they are running the code, they don't realize the program is slow. So meaning that now they assume it will also run. Now think of somebody who will use a mobile phone somewhere, or assume of somebody mobile phone having 512 MB of RAM. That's now another thing. And then they are using a very old browser, something of the sort, or they are using a very old Android phone, going even to Android 5, assume something of the sort. So you have to now know, how does it perform in such cases, and you have to tell. That is why you see, you have to write in your software performance, and you benchmark in different applications. How does it run? You have to tell them, and you have to be keen and tell them, this is how it is running, this is how it works, and this now the performance. You tell them, when assume you use a 4 GB of RAM, or you use at 8 GB, it's faster than when you're using assume a 512. You have to be clear on performance testing and everything. Another thing now is security testing. You have to check end to end now. How is my application secure? Is it really secure? The patient data, or assume the data that I'm taking, it's sensitive, yes? How do I keep it? How do I manage it? You know, you might be a startup, but your data is leaking, and you might even assume you are just designing a EMR, electronic medical record keeping for an hospital, and then their data is just leaking online. Don't forget now, those people, whenever the data will come out, people will just be exposed. How are you doing? You have to check, is really your data well encrypted? How then is the encryption basically working? Is it storing it well? How is it secure? You have also to check whenever you talk about security testing. Also now the database comes in. How is your database? Are you sanitizing values before they enter your database? You have to check such things, because somebody might even decide to drop all your tables. Assume today you are in Ghana, you have an electronic medical keeping record, and someone enters into your system either through where the intruders, they enter into your system, and then they just send a command to drop the data, the database itself, all the tables. Now you can assume that it's carrying all the medical record in the whole country. What happens? People will just be in less. So, and you have also to check that thing. Then now another thing you have also to check when testing now is usability testing. Now on the usability testing now, it's basically you hear something of the user experience. How now does it? How is it? How are these buttons now aligned? Assume how does it send the data? Does the application even keep the user to just be there? The way I know some of you are just in this application like Facebook, Twitter, because they are just keeping you there. They're just responsive, and they are just doing what you want, or even assume WhatsApp, something of the sort. Now we are talking about now the usability testing. Now it should be user friendly. So meaning that when a user takes your phone, takes your software, they can be able to test and just have the experience and be able even to well navigate. Remember, we said the code is the music you're playing. These are the lyrics. So the point is, even when the user doesn't know anything, they can be able to maneuver. Let it not be such complex, because you're not only designing things for technical people. You are designing for somebody who is not that technical, and it's very important. Remember, this is not rocket science. Another thing now is we talk about the regression testing. Now, on regression testing is, remember, some of you will end up adding new updates or new flavors to your software. Now, every moment you change your software, you have to retest it again, test the whole of it. It's very important, and it's so important for you to be able to understand that. Then I will go to now the next thing is techniques of testing techniques. We have to talk about now the technique that you can use. This just out of the blue, that is basically black box testing. Now, whenever we talk about black box testing, yeah, you're just testing. You don't know what it is. You're just writing classes or assume functions just to check. Then white box testing now is that now you are just looking at it like now you know what it is and you know what you are targeting. Now we talk about the gray. Now on the gray box, now you can involve, you can either know or you don't know. Then we have to check about something else, which is basically now the boundary value analysis. Now on the boundary value analysis, now this one comes as a result of assume we have inputs. Assume you have a form, user is just entering values. It's very important for you to be able to test, is it really working? Is it really working even on different platforms? How does it respond? Because I know, remember, some of the libraries you might use or dependencies, they might not be working in some browsers or in some versions of the mobiles, either Android or iOS. They might not be working. You basically need to see if they are really working. The libraries that you're using to implement the inputs, you basically have. Now, on the equivalent now, partitioning now, here is now, you have to test now, how are your tests now scaling? Are they really leading you to do something better, or they're basically just they're just throwing you in the forest? You have to look now, how are you breaking down? Yeah, on the now equivalence partitioning is you have to break your tests smaller, break them and then test small by small, because now these were now on the equivalence, because when it's small by small, you can also equate to something and assume you get what is this value after this function does this and this. It's very important. And then now on the other one is the decision table testing. On the decision table testing now, you have to now assume you have to write things like, assume there are some of you who are having a software to calibrate, because assume you are designing a machine today for anesthesia. So basically, you will have constants, which are basically just, you need to use them for calibration. You need to check and tick, are they really passing what basically we wrote from the initially? And then another thing is state transition testing. Now, on the state transition testing, you have to know, there are people here now who are using, I know, libraries, like assume there are people I know who are using React and assume Jetpack Compose. There are libraries now to state manage things. These libraries, what you have to be keen and careful about is, how is the state is changing? And you have to be very careful because on the state transitioning, remember, sometimes they end up lowering performance. So it's so important as the state is basically transitioning from one screen to the next, what is happening in between. There are some softwares they are not even usable. You click on them, they're not even making you feel like you are just you want to use that software again. It's very important. Then another thing is now on the point of the explorative technique. Explorative, now you have to just check your software the way it is, and now check now which point can I target, blah blah. You are just looking at everything, and it's basically you have to explore your software, just fall in love with your software, and now check now where can I implement these and these and these other tests. Now on this other one now is something we call hand hook testing. This one now comes hand in hand. Remember, you are having your backend. Some of your applications are having backend, others front end. Now, and then you're also communicating between the two backends and front ends. Now, this one now said and done, that one now means now you have to check, like, am I really receiving, assume if it's patient data I'm sending, you have to assume, write a test that basically can check really the data that is coming from the back end. Is it going to the front end, or from the front end, is it going to the back end? You have to now do back-to-back testing now. You have to be sure and aware, really it's responding. Now, then on the other now, pair testing, I know some of you have heard something of the pair programmers. There are people who program, the company I am in, there are two guys who basically just do pair testing. What they do is, one is writing the classes for testing, the other one is writing the software. So basically meaning that, and they first of all start writing the test, because assume if you write your software from the test point, it basically means now you know the coverages. So that one now is very important. Pair testing, you can use your individual, they are writing the test, and then you yourself, you're writing the software, and they can use it to test. Okay, cool. Is there any question there? No. Okay. Okay, great. So we go to the other one now. You have to remember something now. On the tests, you have to do something we call test planning and test executions. Now, on the test planning now, what you basically are looking at, you are just checking the objectives or the goals now. Assume now you are getting the values for the blood pressure. You have to check what are the objectives for me to do this and this. You have also to check at the scope, what are you really covering? And then from there now, you have to now look at how are you approaching the test. And then from there now, you go to the next step, which is basically you execute. So remember, you must test plan and then you execute. And it's very important. And because that one now enables you even to follow the standards, it's very important when you plan yourself. And remember, work from the goals. Goals are very important, because I know each and every startup here has a goals. So the point is, even when you're writing the software, write it from the goals. That is how it will freeze. And then also write it from the point of even where users are just giving feedbacks. It's also very important, another thing. So, and then the other thing is the test automation. Now, whenever we talk about the test automation, it's basically what we are saying is we are putting this software, automating it. Now, basically, it's not even us who are also doing the testing. Remember, someone might sneak in a funny library, or someone might sneak in something that is basically not required. So whenever we talk about test automation, you can automate them. And I know people here, some who have dealt with GitHub, we talk about GitHub, assume the rest of the Bitbucket. So when we talk about GitHub, Bitbucket, basically they give you a platform and frameworks basically to just test and analyze. Basically, because they have something we are talking of Jenkins, Travis CI, and Sarkozy. And there are very many frameworks for basically just doing the test automation. This one now means whenever the test fails, the code is basically not pushed to the master or to the main branch. So basically, because that one now means it says for it to go ahead, first of all, because there's a pipeline, first of all, we've set here, it's checking when the code is pushed to the GitHub or assume the Bitbucket. It's just checking, does it pass all these tests? If it's not passing all those tests, then what do we need to do next? So, and that's the point now you need to remember. And when you automate testing, it becomes easier even for somebody who comes after you. And I will keep on repeating, because they'll not push things, or even assume you have a junior developer or in your company, they will not push things they are not aware, because they will see when they push and when they create a pull request, there is a fail. The code has basically failed, and it has failed because now there is the setup you set to automate the test. It's just keeping on checking the things in your code, because assume you are using library code base is basically entirely on C. And then someone now decides now to push other code, assume like JavaScript code. So basically, whenever you've written the test and the automations and what you basically need to see, it basically means that they will not be able to, because at the end of the day, they will not pass and they will fail. Once they fail now, they need to come back. And you remember now, sometimes people create the notes in some of the notes in there. So it's very important. And that one now means now it's also for the security. Because assume you hire a developer and they just insert malicious code in your code at the end of the day. And it's so important for you because you keep on checking, and it's very important when you automate the process. So the other thing now we have to go, we talked about the quality assurance now. Yeah, now, whenever we talk about the quality assurance now in the health, it's very important. Because remember, I talked when I sent the quality assurance, I see now, these are the industrial standards that are basically governing the monitoring of your software, the delivery and everything. And remember, since now, assume most of you and some of you are designing the health software, there are some of the guidelines, basically you have to keep on checking. And these ISO standards keep on getting updated because, and as they keep on getting updated, it's very important for you to basically know what they are. And the point is, whenever assume you are designing assume Anization, it's very important for you to go to the ISO website, check their what are the requirements assume for Anization software. It's very important, but they have outlined basic standards which are basically assume like ISO 900-2015. Basically, this is what we are looking at is basically like just a QMS. Just it gives you a guideline or basics now of how to certify and all the regulatories basically to just follow. This is very important because assume whenever now you are designing a product, you have a customer and there are regulations also to be followed. And you guys, you are dealing with the patients. Then another thing, when you go assume to ISO/I/EC 2212/2017. Now, this one now talks about now the systems and the software engineering. This one now, it will talk about the life cycle processes. And this one now, whenever we talk about the life cycle now, it's talking about the development processes, the requirement of such a system, the design, testing, and the maintenance, because that is very important. And you see, it's very categorical. And I know some of you are designing the software for health. Now, the point is this, you have to at least, how do you service your software? How is it maintained? How do you plan regular updates? It's very important. And then another thing ISO will always also require from you is how are you testing it? Are you sure really what you are delivering is doing what it is doing? Then your design work. The design work now, yeah, remember I talked about the architecture of your system. So because when you're submitting such a system assume for compliance, you will be asked for such things. How is your architecture? How is the communication between? Because whenever you talk about architectural design, remember I said you're talking about from the front end where you're hosting your, from where the application is coming from. You're also going to where also you are hosting that application. Assume you have load balancers. Assume you have other communication protocols. Assume you have something like ingest engines, basically to just churn data now and then. So you basically have to talk through and you have to basically just have the design of your software. Because remember, don't say only the design is for the guys who are in civil. Don't say the design is for the guy who are doing electrical designs. No, the design also in software also applies. In the company I am currently in, before we do anything, first of all, we draw things and we design things and we see communication of things such that now assume 2 years from now, if I'm out of that company, they will bring another developer and the developer will be shown how we implemented a certain service. Because on the design, there are some of the internal tools ourselves we built for the company. That one now means now they're not getting used externally and the developers never interacted with. So basically meaning that if we have a design of such a tool and how the communication is happening in between the developer, things become easy. And that is why now ISO is so stringent on you guys on matters of the system and the software design. And also you can also check again, which is basically now also 2011. Again, it's an update of this other one. It's also this other one now also, it's all about the data, the modeling, because I know some of you have got the data and you have to basically do the modeling. And these are basically the standards that are followed in so the design. But the point is this, whenever you are dealing with ISO standard, please assume you are writing a software for Anization. Go check, do ISO have this? Or what is the equivalent of that standard? It's very important for you to know that. And remember, there are very many ISO standards. And the point is this, if your software, at least it is compliance, it will not only sell in your locality, it will sell globally. And that's one thing you have to note. Because if the software is good, it is compliant of such things. And I sent this. because we have been having a problem where now African softwares are not selling assuming in Europe or in Asia. The point is this: some of our software sometimes don't meet the standards. And until I started working for an American company, that is when I understood that. So the point is this: you have to keep on checking on the compliance. What is it required? I'll now assume, because I know some of you have a software. Do you have somewhere where I assume the application crashes, the user can report? Do you have assume like a bug reporting rather before the user assume goes to a website and rates it, gives it raw stars, or goes to the Play Store and now says how bad your application is? Do you have somewhere where basically just the user can be able to report there is this incident and this incident, I have this phone? You have to implement that because you are dealing with health. And remember, we are dealing with life. Whenever it is health, this is life. So it's very important for you to remember that. Good. So any question now? There was somebody who asked about ISO. Someone asked about yes.
That was Stephen Kashobia.
Yes, Kashobia.
Yes,
yeah. So
yeah.
Go ahead, Isaac.
All right. So yeah. So my question has to do with ISO certifications, right?
Yes.
Is it necessary, though? Do you think it's a good idea to take it upon yourself to rather write the certification for the specific track for the ISO?
Yes, they are very required. They are very much required. You can't move beyond your scope without them. They are there. When you go, assume in the country you are in, assume you have the local, the one that passed the product. One thing they will ask you for is it ISO certified? That's our question. And that is why under some of, I think Wangari can tell us about ISO certifications. I'm not aware about so much about ISO certificates, but I have seen there are some that even are bought. I don't know.
Yeah. So okay.
Yes. Wangari, explain on ISO certificates.
Yeah, so basically, if you want to expand your scope of your customers outside the region of where you're operating, the best way in which majority of your countries will be able to accept is basically aligning with what the international regulations are for you. So maybe a question for you, Jim. Some of us here have just the software; they do not have the device part. How would you explain to them in terms of quality assurance and how the standard will be applicable to them, since comparing that with the software applications per se, or product software? Yeah.
Okay. Yeah. Re-ask a question again. Okay. Cool.
Yeah. So I'm asking, with the experience that you currently are dealing with a software application, how do you inquire? How do you inquire about the software you have to apply, the international standard that you need to apply, and plugging into your current software application or product application?
Okay. On that, what I know is basically assume now, since they have a software and you are dealing with a specific domain, assume that now we are having something like, I repeat, anization and something of the sort, or you're designing something of the sort. There is a standard basically regulating that. So you have to basically get a certification for that, even in as much as it is the software. And the point is now, apart from it, because they will divide it into smaller bit, what is it? Does it do? Does it deal with the customers? Yes. Does it deal with the user data? Yes. Now, if it deals with the user data, how are you dealing, assume, with the privacy and the something of the sort? Is it coming from one region to another? Yes. Now, from one region to another, now you have to observe, because assume a software in China is not the same software in America. They have their regulations there, and we have the regulation here, and we have the regulation in America. So those are some of the things. But what I know is you have to adhere as per the certification. I don't know if I've answered that.
Yes. You've answered that. That actually applies both to the medical devices that actually have onboarded a system, a software system embedded in it, so that to make easy communication with the end user, having a very good display as well, some of those UI UX understanding of how to incorporate that into the actual device. And the same standards assigned here, even for ISO 13485, which majority of it is enhanced towards medical devices, quality management system that is acquired, will be acquired as for other applicable appropriate standard for software embedded within the medical devices. So I think it's a whole rounded place, whether it's a device, whether it's a software application, you have to adhere to the standards per se, and also pointing out back to the regulatory documentation process in terms of the architecture design, all the way coding system, you've been able to achieve that. So that is the only way or evidence in which you are going to show that you have adhered to the quality assurance of your product. I see a hand raised. Isaac, go ahead.
Yeah, so this one, we have a web application and then a mobile app. I wanted to get clarification on to be ISO certified for the application that we've built. Does it mean that one of us has to be ISO certified to write the exam certification itself before we'll be able to, before the system or the application will be accepted as, and of course adhere to all the procedures and consent that the ISO talks about? I wanted to get that clarification.
Okay, yes, if you're dealing with health, you will need to be certified. That's one thing. Because assume, I get your point. Sometimes there are things you're using in your application, assume the dashboard and the rest and the colors and everything. But you should be aware when you're talking about the Mendico. Mendico is somewhere where the color red or the color black means something, right? So basically that one now means they'll need, have you really qualified for that? Yes.
Right.
ISO is not only for the hardware, it's for also the software. Because some of you have seen the medical equipment. I'll give a simple example. You've seen in a movie where there is a line moving, saying TTT and the rest. One thing you should have observed, all machines behave the same, the medical machines. Even if you watch a different movie, assume it's a Siemens machine, assume it's a GE machines, and the colors are the same. The point is there is a rule governing that, meaning that you can't go beyond that. You have to re-implement it as per that.
Right. All right. Thank you for the answer.
Okay. And another thing you should notice when you talk about the ISO standard, you can sell the stuff in your country because assume the local and the rest. But now going international, it's not a certification for you to go international. It's like assume I myself as a biomedical engineer. If I have to operate in US, I have to be IEEE engineer. Like I have to first of all get certified by them, and then also I have to come to the country Kenya. Here I go assume to any engineering governing body here in the Kenya country to just certify me. So because they can't trust your gadget if it's not ISO certified. That is why in everything you always see ISO certified, ISO certified.
Yes, right. Good.
Yeah.
Thank you.
So Isaac, I think you're from corporate health, Ghana. So probably what you can do is identify all the regulatory standards. So there's ISO standard, the IEC standard, the IEEE standards, and any other regulatory standard that binds within what you're currently building up for corporate health. And now, once now you want to go outside Ghana or the rest of the region within Western Africa, then you will already have onboarded what the standard had said. So moving beyond that, then you get now the ISO certification level whereby you can be easily acceptable, not only Western Uganda, but the rest of the world once you want to scale up to other regions of the world.
Cool stuff there. Thank you.
So you can just you can just adhere to the basic standards or whatever you currently are building up, just adhere by that. Doesn't mean that you need to get standard by right now, but that's adhering what the standard is saying, so that when you get to that region where you need to scale up, that means you have to get the standard certification. That's when now you reach out to that level. but you can currently just adhere to what those standards are applicable to you. And then once the time comes, you're already prepared, you already have the full evidence to indicate that you're very qualified for the ISO standards. Yeah.
Yeah.
Thank you so much.
Yeah.
All right. Thank you.
They are very important. I will tell, what is his name, Ben? Or what is you called him, Wangari?
Sorry?
What is his name? I will give him
Isaac.
a case scenario. Isaac, sometimes back, we were designing a ventilator. What I basically just put us back sometimes was the ISO standards. You know, because now they assume when you follow them, they will ask you the life cycle of your ventilator, and it has only run one day. That is when you realize now you need to know how long does it run, something of the sort. They are very important, those standards.
Sure. Thank you.
Okay, cool.
All right.
So we go to the other thing now that's very important to all of us is basically what you talk about bug tracking and bug reporting. Now, the point of what you call bug tracking is you're identifying, assume the calls and the fault of the program. Assume the user tells you the application has crashed. Because you'll hear about that, the application has crashed, something of the sort. Now, currently, we are having tools basically to do that. And the one tool that we are using internally in our company is what we call Sentry. Some of you have had something to do with Sentry. So Sentry basically will be where we put it in the user's device as the device is also running. So, and then it will send the metrics now and then of what is happening. In case of a crash, we'll be able to see the crash and the crash error. What was that crash error essentially? Because the user might tell you, when I open my application, it just dies. So you basically need to at least do that. It's very important because remember, you are dealing with health, and whenever you're dealing with health, it's crucial, and someone has entrusted their data to you. So when the application crashes, now they will feel something else. So after that is now, and apart from that, now I will go now to the developers here now. On the bug tracking and bug reporting, we talk about assigning severity to the bugs and the levels and the defects now. Now, what we talk is that assume you're having a software and you see you'll not be able to fix the problem that is basically there. You have to assign the problem to someone, assume that, because I know most of the developers here are using GitHub basically to manage their code base. You have to alert your users, and it's very important, please. You have to assign the person who will take care of the bug, and then you have also to make sure you alert the users. It's very important for them to know, assume the version 1.11 is basically not working. 1.01 is basically the one that is just working. And we shall see how the versioning goes. And you see how important versioning is in the software. And then now another thing is that yeah, you just label the defects and their causes. And I've said the point is you can use softwares that can assist you, basically Sentry that can be able to assist you to get the crashes report and the rest. Then, and it's a paid software, but I don't know much, but it's not that expensive. We are using it to monitor our services. Then the other one is assigning ownership for the resolution. Now, this one now, assume already now it's me who was working on that part of that is basically crashing. Now, you have to assign them and tell them basically how it is. And then remember, when you assign, assume you are the senior dev, be precise, concise, and also have love. Because when I mention about love, I know there are some of you who have gotten insulted during the code review. Someone writes for you something that you're not happy. But have love and show the way of how basically you're just going to mitigate and make sure at least you have the solution of how the code will basically be. And because this one now means that's why you have now to use the Git for version control, so that now you'll see who handled a certain problem, whether the dev that is already in the company or the dev who is already gone. This other one now is the tracking the defect. I've talked about the Sentry. You have to track the defect, and then you have also to track, was it now resolved? It's very important. Was the problem resolved? Because you might be having a bug that was assigned to somebody 1 year or 1 month down the line, it has not been worked on, and it's very, very important for you to be able to do that. It's very critical and very, very important for you to do that. So on that, we go now. It's very important. I talked about a bit of what we call now continuous integration and delivery, CI/CD. I know most of you are just here. So I say basically, because in your CD, you basically build, test, and you deploy your processes. And then most important thing about CI/CD. It is you're protecting your code base, the major code base. Remember, you don't want it to have technical debt, meaning that at least the code that somebody is pushing to the the GitHub or to the Bitbucket, because there are some who are using Bitbucket, others Mercurial. So basically now the services you are using to push your code is basically you are testing people's code before it goes there. What is anything malicious that is going there? Is it really passing or test that basically we've told it to test? Is it really as per the libraries? Assume the node module. Is it assumed, because some of you are using the node module versions, those who use JavaScript, there are some who are using Java, assume you're Kotlin, the version that you want to be pushed to the main code base, is it really the one? Does it go really below? Because now on the CI/CD will tell you, because if somebody introduces, assume a very low library that was designed a long time ago, that now means it will bring problems. So CI/CD enables you basically, you can be able to write those tests and you basically just put there. And I sent their frameworks, Jenkins, you can use Travis CI, you can use those ones basically just to automate the process. It's just basically a pipeline, you just write the pipeline to do that work. And then because what we are looking at, remember your code, one thing we have to, whenever we talk about system design is efficiency and reliability. Remember your software, one thing it should be simple. The other thing, it should be efficient and then reliable. When the user wants it, can they press the button? Can they use it? Is it really efficient? Does it really perform the way it's supposed to be able to perform? Can they use it at any time? Assume now, because I know some of you are even on the reliability point also, it's very important. I know you are correcting user data. Assume now, because we always, whenever we do mobile stuffs, we always say, think about offline first. So whenever we think about offline, assume a user might be in a place without network, and then assume they are sending the data. Now, does it mean if there was no network, that data would not get sent? That's one thing now you have to be able, meaning that the system should be reliable. Now, and whenever we talk about reliability, there's another thing we have to talk about. It should be fault tolerance. Fault tolerance means no matter what, no matter, assume your API is receiving how many requests, assume now the system will not fall or the system will not go down, because there are some systems, assume even here in the country, Kenya, we have some systems that are, when you assume 1,000 people access at the same time, the system goes down and crashes and nobody can use it any longer. So it's very important when you are designing your software to think about fault tolerant. How fault tolerant is it? Assume while you're hosting your services, how what the RAM are you using basically there? What are the type of the storages? What are you using? And then another thing is also, because I've seen as a startups, as you continue, there's something you'll do. You realize we always talk about base 64. I know some of you are saving your big document, assume 50 MBs of document using base 64, pushing it into the database. And that one now means now what you're doing is basically you're slowing your database. That is a technical debt you've introduced. Assume when you start fetching and your database start locking. So meaning how many users will be locked out? At least start thinking of using other object storage. Assume like S3 bucket storage, but those are expensive. But there are some that are basically cheap, and you can check services that are cheap to just do that. Because your database, let it be efficient and efficiency. And then another thing I have also to talk about here, I did not mention, is about also the database. You have to replicate your data. Be keen, because you never know when we always say when problems arise basically, and you lose all the user data, because you as time goes by, you realize someone even might hold you hostage with your data. So how do you recover it again? Someone might end up encrypting your data, the whole data in the database. So you have to make sure there is the replication of your system somewhere, and you're storing it somewhere and safe and secure. Then we will go now to, I talked about now the code demo for basically for testing our BP calculator that will basically just checking the BP. These are tests that basically we write. And when this test basically is written now, you see it's basically covering all the case engines. Assume now I give it a string and I don't give it an integer. So basically this one now means it will always end up raising an error. Or assume I give it a value, because assumes historic and the historic values of the human body cannot be below. So when I write this, assume if I started writing these this class to basically just test and check if really my program is really working on well, we can automate it. We can automate it. So, and that one all said and done, when I do this, when I write all these tests, I'm basically checking in each and every. Assume I'm just checking what is happening, and assume because this was a dictionary we basically formed. This one, it was a dictionary that we basically removed from if else statement, if you a lot of nested if else statement, we just put it in a basic dictionary, which we basically now, and that one now assume now, yeah, I'm having a value -10 and 80. So assume the user enters -10, or I assume -80. So basically meaning that now here, when I test, first of all here, because I'm testing my program, it will be able to tell me really if my program is working or basically not working, or it is accepting this and this. And then from that point now, that is when now I'll basically know what do I need to do. And for example, that one now it tells me then I need to define the type of data that I get. Is either a string, it's either an array or something of the sort. What am I getting? What type of data am I expecting? And the tests basically are very important. I never knew the importance of the test until our company basically, there was a code that was basically pushed by the senior dev direct to production. He disabled all he disabled the test. And then when he pushed it, it crashed. And then everybody, we were woken up at 2. 3 weeks ago, and it was so problematic. It was so problematic because we don't know where the problem is. We pushed to the main code base, and it was really, really hectic. So after the testing, now we see these bugs will basically be gotten from the previous code. Remember, the previous code, we were never doing what we used to call input validation. If you could have remembered, we were never validating the inputs. I'll go back to the code. Here it is. If you check here, there is no input validation. Here it is. There was no input validation basically. So that one now means when I write the test, it is basically giving me the input that I'm basically giving. Is it a positive? Is it a negative? Is it assume? Is it a string? Is it an array or everything? It will basically draw. And then another thing is now I'll also be able to get the range bug. That is very important. The range means now assume historic, and you are very sure historic of the human being body assume comes from 70, assume to 150. So that one means if it goes, and you are aware that maybe it might never go below 50. I'm not saying it will not go below 50. It's just a case, giving a case scenario. It will never go 50. That one means you already have covered, and you already have put it there. That's very important, the range. And basically, whenever we put the range, you'll basically see the range it's out of. So, and this is now the new written code, basically, where we are just covering everything. You see what we are doing is we are checking. The first thing is it should be greater than 0, assume. This historic should never be 0, a negative value. So because if it's not that, then we should raise an error. So, and then another thing is that now, because it will tell us invariant values, or assume now, historic is never supposed to be greater than, the historic is never supposed to be greater than historic. So that one now means whenever someone inputs a value that is where the historic is greater than historic, now it means now it erases an error and it tells them. And then now another thing very important now, here we come to very important thing. Please let your errors be well written. Let them inform the users. So the point is, assume that I know there are developers here. Some of you know you might write a code and assume the database disconnect. Assume that is the error you are sending to the user. Now, how does the user know what is a database? They are not even aware. So the point is, structure your errors as per your domain. Domain meaning that now, assume now even we will have, assume you are having a specific sensor to do something, to get values from something, then send. Assume that sensor is not attached. Tell the user with a specific error, this and this is not attached. That's the point. That's what I'm saying now. You have to come up with a way of writing nice errors that basically introduces the problem currently. And that one now means what we are doing is we are able to debug. Someone is writing on my screen? Okay, cool. Okay. So what I'm saying is now it becomes easier for us to be able to debug. So once that one now is said and done, please, it's very important for you to be able to write well-structured errors for the users. And then remember, users are not technical. Not every user will be an engineer. Not every user will be an electrical engineer, mechanical, or a doctor. Structure the error, assume you are getting from your gadget, or assume from your software, such that it will be able to introduce the type of the problem. Let it be an explicit. Don't write for them like there was a certain machine when I was back in the university. There was a machine we were told to do to just to maintain. But the problem with the machine, it was an old machine for 2000 there. The error, it was just bringing errors in terms of numbers, just give you an error, 515, 20, X, R1. And now you don't even know what that error is. So basically that one means the errors become a problem. And even when you go to the service manuals or the user manuals, there is no such an error written. So you see now, it's the machine drawing the errors and now bringing to us, which we even don't understand what it means. So it's very important for your errors to be known by the user and very easy and simple to be interpreted. Cool. Then we'll go to the next. So I'll now go to is there anybody with any questions from where we've reached?
So far, so good.
Okay, cool, great. Okay, we'll go now to the basic best practices and standards. When we talk about best practices now, these are just basic principles. I know some of you have done computer science and you've been taught a lot of basic principle. I know some of you are following like one principle, we basically call it SORENT principle. Java developers follow that one a lot. I've interacted with them and they follow such principles. But now, there are the basic principles you need to know. And as a developer, let these principles be enshrined in your hearts. It's very important. The principle basically is what the principles, what we are talking about now, the best practices and standards, the industry standards you're following, what they're just enabling you is just to write something we call a more readable code, maintainable code, efficient code, and then how do you format, how do you handle errors, and then assume now when you are picking a language, how does it handle error? Does the language scale? Because assume some of you might be wanting to design their own database. Is the language really you are choosing? Is it really that good? Does it have speed? Assume you want a hardware to run in terms of microseconds. Which language do you want to use? It's very important now to understand at least standards of things and conventions. And then another convention is also very important, like naming. Some of you know something. There is a camel case, something of a sort. Like there are some languages you must start, either classes, you must start with a capital. There are some other languages, classes should be small. So functions also should be capital, small. So those are some of the standards about a language you should be able. And the important about them, it is they ensure readability. Because I said, remember, this code is the music. Can you own the music such that somebody, when they come again, they can sing the tune? So such that now we don't need to struggle. We don't need to hear blah, 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 because if your code is not understandable, it will basically be just blah, 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 all over the code, and it will be chaotic. We basically, our CTO tells us, the one day he told me, Jim, you've written a chaotic code. So basically that one means it is pathetic. I have to rewrite it again. So that one, it pains, but at the end of the day, what we are looking for is readability. Think about the person who comes after you. It's very important, as I'm saying that, because you are startups and some of you will become CTOs. Assume somebody, or the CEOs of the companies you are in currently, assume somebody who comes after you, how do they inherit the code? How do they feel? Do they really like it? Do they really love it? Is it really reusable? It's very important. And now that one I'm said and done, there are some languages, assume Python, there is a style guide Google gives out, assume there is 4 spacing, 3 spacing, there are some languages that are that way. And that one now said and done, assume when you are just spacing, some of you know you use Vim, I don't know, something of the sort, in a IDE, it doesn't matter, but please remember the IDE you are using, let it at least be able to support linters so that you can basically now format your code. It's very important. And then now there is a Microsoft C# coding guidelines, and now Linux kernel coding style. It's very important for you, assume you're developing something in a certain language, at least know how is it done, how is their conventions, how is their naming, how is their keywordings. Very, very much important. Very important piece. Very. Then another thing we have to talk about is this, the code reviews. Now code reviews is basically whereby before the code now is taken to the main, assume it is merged to the master or the main branch. Now, the point is the code must be reviewed. in a company. In as much as I know some of you also are just pushed to the production and the code just goes and breaks things. At least if you are two, three developers, tell someone at least review my code, this and this. And then on code review, be very careful. Not everybody should review. At least somebody who knows what happens. And these people should be able to identify the errors, correct, and even also improve on your code. So it's very important. And then now, as a developer, assume you are entitled to review the code. Please let it be, and I'll repeat it again. Please let it be. You can check line by line, because if you don't check line by line, you'll push things to production that will end up causing technical debt and what we called technical debt. All you realize what you're just pushing is duplicates. At the end of the day, duplicates, or even somebody is not even doing the work that you hired them for. They're just doing their own stuff. It's very important. And when you are reviewing, what you are doing is now you are trying to catch the bug. You are trying, assume you are trying to check the printing style. This person basically did assume, why are they using 4 spaces, 3 spaces, blah, blah, such things, because you have to have your own internal way of doing things. And then now from there, and then that one means you'll follow the best practice on the code reviews. It's very important for the code to be reviewed before it is pushed to the master or to the main branch. It's very important because you are identifying the problems and faults. Assume someone writes a query that gives someone solely access to a database, and assume an hacker somewhere, because they have intrusion tools, they basically just get the whole data. Who will you blame? And you are the one who pushed it to master, and you're dealing with hell. That one now means even your company, the licensing might go. So it's very, very important for you to be able to note such. And then another thing now here is assume documentation. Please at least document something. As what we do in our company, assume we might not write it in a document one, assume I have work management tools, as we use ClickUp. I know everybody, some of you are dealing with ClickUp or what do we call it? Or Notion. I don't know others use what. I don't know. There are some other tools you can use for just this work, documenting. Just you can document what is basically happening and what is happening in each and every. Assume the main parts of the program. You might not document everything, but the main parts and the main logic, you can be able to tell this is what is happening and this is what is happening, such that when someone comes again, they can be able to onboard. And also another thing is now you have also to have, when you talk about documentation, use a manual to check what we are calling user. Hello, can you hear me?
Yeah, we can hear you now.
Okay,
I think
cool.
you're breaking a bit, yeah.
Okay, sorry. It's okay. So what I'm saying is that like the user can be able to basically just read what and even the basics of onboarding and everything. Like the user manuals. To some who are dealing with hardware, yeah, remember the hardware will break. That one now said and done, it will break. That one now means you need to introduce the user manuals, even to guide the user how to operate it. They don't know. Remember, someone told me this. You assume everybody knows what you are writing. Not all of us are dumb. It's only who knows what you are writing, how it's supposed to be done. So, and that one now said and done, now you have at least to have manuals to direct the user. And then another thing is the technical specifications. Now, the technical specifications, I've sent this. I know some of you are designing both Android applications, are designing the web-based applications, assume. Now, the point of technical specification says, the point is, assume it is not running on Opera version browser, this and this. You need to be able to assume it's not running on Chrome, assume it's not running on Safari or Gecko. You basically need to say, you have to be specific technically. How is it running, or what type of an internet is required to access you, or what amount of memory is required for your application to base front end. It's very important. It's basically going. And that one also said and done how the API is basically going is they need somebody who is building on the front end should at least see somewhere where now the API, this route connects this. This one goes to this. This one goes to this. At least you can use the documenting API softwares. There are very many. The Swagger, and you can just name them. There are very many API documenting softwares. It's very important. And because it makes it easy to use and to maintain. Because what you are talking about, if your code is not maintainable, then it is full of technical debt. And if code is full of technical debt, then your startup can't survive. Because at the end of the day, things are changing and you need to keep on updating your application. And if it cannot get new features, problem. Because people will not use the features they are using now 3 years down the line, they are still using them 5 years after that. It cannot. Then another thing is now another point apart now from documentation. And please remember on documentation, I'll mention it again here. There are people here who might be having the hardware. Whenever you're having hardware, also make maintenance manual or just maintenance manual, basically meaning that you are also involving any type of error that might be thrown, any type of error that might be involved. It's very important because when you involve that, it simply means that the user, before they contact you, they can be able at least to do their to calibrate their machine, to do this and that, and to do this and that. Whenever you have an hardware, please make sure to have maintenance manual. And then also another thing, and I have to keep remind you on this. Whenever you have the hardware and you're incorporating a hardware, please remember also to make sure on the UI part, you're showing the user where to calibrate. The machine should not start directly and go without getting calibrated. Remember, this is human life and some values might have changed. It's very important for such things. It's very important. And you need to put it either in the user manual or the maintenance manual. Then we'll go to the next thing now, which is basically agile methodology, which now everybody is also aware of. Now, whenever you talk about agile, I talked something when I started, I talked about your design at least, let it be modular. What I talk by design being modular is basically you're breaking your problem into small bits. And when you break it into small bits, you assign to someone. When you assign it to someone, that one now means said and done. Whenever you break it to small bit and you assign, it means it is easier for the program to be written faster rather than assigning somebody design this, do that, and they are not even aware. Break it into small problems and then put it, give it to people. And then that one now means you can iterate, you can go through all those problems. And then that one now means now people will be efficient, and then you can be able to track what has been done and what has not been done. It's very important when you just take agile methodology is basically just a principle. You can take it and you can look on it more. Then I talked about testing standards, and as I said, please let our code be at least standard. It's very important. These are best practice. Let it be standard, such that somebody, when they look at it, it's music, they can follow, they can maintain, it's readable, it can scale, it can get deployed anywhere. So then the other thing is now on the security standards. Now on the security standards, please remember, you are dealing with networks, you are dealing with databases. Please, here, and also you are dealing with sensitive user data. And that sensitive user data can put you in. I think you need to go check the UK, their way of how the companies. There's a company I've seen that has been fined $393 million yesterday because of user data sensitivity. So it's very important for you to know. And some weeks ago, you saw the TikTok CEO getting grilled in the US. If you basically saw the Senate, it's very important. Some of the countries assume in the US and the UK, they are so clear on the user data because now they want to be assured their user data is protected. Since you are dealing with health, protect the user data. Very critical, meaning that even what you are avoiding is the SQL injections. And then also another thing is cross-site scripting, which basically might end up hijacking your website. I know there are some, even where me in the country, there are some government websites you basically visit, and even I know in your countries, and you'll basically find it's a government website, but it is full of hands and pornographic stuffs. And basically now you wonder what happened. So that now means there are some guidelines that were basically never followed as per the letter. And now to avoid that, please remember, you have to have good security measures, either on the network, on the encryptions and everything, and even the hosting places. And even how do you secure your keys, the certificate, the SSL certificate. You need to be aware, not everybody is supposed to have that. It's very critical. Even, for example, assume the company machines, the company machine that stores all those certificates should be very, very secure. Not everybody should access. I myself, where I work for, I only access what I'm given allowance to. I don't even see assume other groups code. Basically, I only see the code that I'm working on, and that basically I'm just reviewing, because that one is for the security and also maintaining the standard of your company. Because someone even might decide, someone might end up selling your code base. Assume if they sell your code base, then you're finished and you're done. At the end of the day, they might put it somewhere there. And that one now means now it is prone to be attacked or everything of the sort. Or they might even push it and the keys, open keys to the public. And when they push it, what happens? You are in mess. So that's the point. Now, very important topic, please hear now, because this one, the one that I'm finishing with and I'm ending with. Whenever we talk about the code now, these are our software now you've already written. We've now handled technical debts. We've at least now looked at the testing. Yes, we've tested our code. And now we've also looked at the best practice, we followed them. Now, another important part now here is the version control. Now, on the version control, I have to and I tell you very important here. Version control, basically, yes, you're pushing to the GitHub, but are you keeping track of, assume users, this version was released, this and this. And now what it means to version control, you are basically aware, assume you are releasing version 1.01. That one now means it will become easier when you have a way of naming your versions. And you can check ways, and you can get, and I understand, since developers are here, you can check ways of versioning your product. That one now means, assume if a user calls you and tells you my product has got a problem, you'll ask them which version. That one now said and done, you can be able to go and investigate, because it is easier to troubleshoot a version you know, rather than assume you're having the current version and it's the one that you are troubleshooting and it's the one that doesn't have the problem. And then another important about versioning is you can revert the changes. Assume you've pushed the version that you thought it's working and then it goes AY to the users. You'll tell them, we are rolling back the changes to the previous version. Wait until this one becomes stable. It's very important. And please, anybody who is doing any software here, track the version. You need to be able to have a way of creating your own versions. And now on the versioning, software versioning, now here, you just do it in a very simple manner. You have basically the language that you use, the GitHub gives you a way of versioning. You can check out to version in the GitHub, and also before even pushing to the GitHub, you can version locally and then you send it. So basically, like here now, what happens is, assume you find a software, some of you find a software which is 1.01. The first one means it's the major version. The second part, which is 0, now it's the minor. The other one now is the patch. The patch, basically, what we're talking about the patch, assume there was a bug that you basically handled in version 1. That is how now you keep on incrementing whenever you change something. And that's now the versioning. And you can check something to do with semantic versioning. It will take you well, and there's a convention, basically. This is what we do and we follow, even in our company. Basically, this is how the versioning we do it. And the versioning is very important because the users will complain the application is not working. But remember, you need to know which version basically is not working. And even when you need to roll back the changes, it's very important to know version this and this was stable. So this and this is not stable. Roll back to the previous version. Very important. Now, like assume now in our BP application, now that we hand the sketch BP, we can have assume 1.001, which is what the initial release. After we fix the bugs that we basically found, now you can call it now, because it's the patch 1.001. And now assume we hand another support for measuring pressure, something of the sort. So now we can write it because it's another minor version. The second one is the minor version. We can basically just 1.10. And now assume now we want to change major features now. Whenever we are moving to the major feature, we now move to the next level, which is basically now 2.00. And that is what basically now, even when you're tracking something, you'll basically be able to visualize it. Now, this is my end. Veni Vidi Vinci. Thanks.
Thank you, guys. So Jim, thank you so much for that very well elaborated introduction for the three topics that you've been able to dig deep into, helping the rest of the team to understand. Maybe I could open it up to anyone who has any question for Jim. Anyone? All right. So Jim, do you have any last words for everyone?
Okay, my last one is don't write technical debt, write the code. That's the point. Yeah, and I'm very happy for also listening to me. It's not easy for 1 hour. I mean, almost 2 hours. We've been here 2 hours. So it's not easy for you to just be there and listen. And I know some of you are my fellow developers, even for showing you are humble and also being there. It's very important. Thank you very much. Also, thank you to the Virgo Africa for this opportunity. Thank you very much, guys. I wish all you all the best in the startups. Write the best code, please. And also this document, I believe Wangari has it. If you want it, you can ask.
Yes, sorry for the last thing. So Jim, in case we want to reach out to you, can we do that directly? Do you have any contact details, anything?
Okay. Wangari, what do you comment about that?
Yeah, Isaac. If you want to reach to him, I can actually, if you kindly email me directly under Winnie Wangari. Let me share my email here as well. If you want to get hold of Jim, you can reach out to me so that I can arrange for that.
Great. Yeah.
I've shared a link for you to have yourself like 1 minute or 2 minutes to fill it in so that we understand if you have any other additional topics you want us to cover, we can arrange for another masterclass.
Then Wangari, I remember they are not seeing me, so I don't know where I am. There is a sort of
Yes,
darkness,
if
but,
you can.
there I am. I look like, yeah, there I am. That's it. Yeah.
All right. So thank you guys. Have a lovely weekend ahead, and I'll share the link of the video on our social media and also through the emails for those who are invited privately through the email as well. I'm going to share that once it's ready. So thank you so much for your time. Thank you, Jim. We'll continue communicating and see you guys. Have a happy weekend and a holiday ahead.